네, 여러분 식사 맛있게 하셨습니까? 2024 글로벌 푸드테크 기술 표준화 심포지움 두 번째 세션에 오신 여러분 진심으로 환영합니다. 지금부터 다양한 이야기 함께 나누겠는데요. 두 번째 세션의 주제는 식물성 대체식품 표준 현황 및 나아갈 길이 되겠습니다. 이번 세션에도 역시 좌장님께서 진행을 맡아서 함께 해주시겠는데요. 두 번째 세션의 좌장은 대구대학교 식품영양학과의 이미령 교수님께서 함께 해주시겠습니다. 이미령 교수님을 무대로 모시겠습니다. 여러분 따뜻한 박수로 환영해 주시기 바랍니다. 네, 어서 오십시오. 지금부터 이미령 교수님께서 진행하는 두 번째 세션이 시작이 됩니다. 그러면 마이크를 좌장님께 넘겨드리겠습니다. 교수님 진행 부탁드립니다.
네, 사회자님 좋은 소개 감사드립니다. 안녕하세요. 저는 오늘 두 번째 세션 2를 맡게 된 대구대학교 식품영양학과 이미령이라고 합니다. 오늘 세션 2의 제목은요, 식물성 대체식품 표준 현황 및 나아갈 길이라는 주제를 가지고 세 분의 연사를 모시고 제가 세션을 진행할 건데요. 멀리 그 네덜란드죠? 네덜란드랑 싱가포르에서 또 미국에서 이렇게 저희 오늘 세션을 위해서 여행을 해 주셨습니다. 일단 먼저 감사의 말씀을 드리고요. 첫 번째 연사분은 성함이 뷔텔라르. 네, 지금 큰 박수로 맞아주시기 바랍니다. 제가 간단하게 연사분을 청중 여러분들께 소개시켜 드리겠습니다. 뷔텔라르 그 연사분은 지금 브라이트 그린 파트너스의 경영 파트너로 재직하고 계시고 2019년에서 2020년에는 플로어 컨설팅이라는 곳을 창립하셨습니다. 그래서 식물성 단백 어렸을 때부터 아주 그 베지테리안이라고 이렇게 말씀을 해주셨는데요. 아주 식물성 식품에 대해서 조예가 깊은 분이셔서 아마 오늘 여러분들에게 좋은 정보를 드릴 거라고 생각합니다. 여러분 큰 박수로 우리 연사님을 맞아주시기 바랍니다. 오늘 그 발표하실 제목은 Current International Standards and Case Studies for Plant-Based Alternative Food라는 제목을 해주실 거고요. 그 발표 시간이 정말 죄송한데 20분이고 5분 질의응답 시간이 있는데 이렇게 발표 시간을 조금 지켜주시기를 부탁드리겠습니다. It's all yours, pleasure. It's all yours. Thank you.
Thank you so much. And I wish I had practiced more Korean while I studied here in Seoul, actually 7 years ago at Yonsei University. And it's therefore a great pleasure and an honor to be here today on stage. So thank you very much also again for the invitation. I will indeed be talking about plant-based foods and international standards and cases. And let me briefly talk you first through about who we are at Bright Green Partners, just so you have an idea, and then we get to the actual content of today. So our vision, and I hope many of yours here in the audience today share this vision with me, is to establish a new realistic balance between people, planet, and profit in the food system that we have globally. And we're not there yet. We will get more into that in the presentation. How we do that is as a consulting firm focused solely on agri-food tech. So all the topics that we see today and heard by the other speakers are at the core of what we do each and every day. And we help corporates and investors get the best insights up on the table to make informed decisions and therefore get clarity and confidence on the next steps to take in this food system. We do that by excellent consulting skill sets and across the globe. So I'm pleased to be here in Korea and to see some familiar faces as well today. Very overwhelming slide, I know. It's just strategy and M&A and due diligence that I want to point out that that's the majority of the work that we do within this agri-food tech space. Well, on to the actual insights of today. I will be talking you briefly through why it's even relevant that we have this conversation here today. I hope this is not new to most of you, but just so that we're all on the same page. And then I will be talking you through some of the differences internationally that we see with food standards and with the regulation mostly, and give some examples as well so we make this actually tangible so that you understand what we actually talk about. So, as hopefully you know, we need novel ways to produce food globally to solve the food challenges that we have, to actually get to that food system where people, planet, and profit are in balance, and to be able to feed the rising population that we have. As said earlier today, not all the countries deal with growing population, but actually with declining population. But overall, we definitely need new solutions to be able to feed everyone across the globe. Well, we cannot increase the land use, and this gives the bottleneck to the current food system and the current technologies that we use, and why we specifically talk about agri-food tech solutions. And ideally, we reduce the impact on climate because, as said, we cannot continue the same way as we did. And today, it makes up already 26% of the world's emission just from our food system. Now, within agri-food tech, there are all sorts of solutions that we've already heard on their hype cycle, for example, in the last presentation before the lunch. Just today, we will be focusing in this presentation particularly on plant-based alternatives. Well, within the overall alternative proteins, there are 4 main solutions that you can kind of classify. From cultivated meat that probably you are aware of, that for example in Singapore, where we also have a speaker from, is already on the market. We have, for example, molecular farming, where actually protein crops, the DNA is being changed and brought in from animals, so that the plant, the crop in this case, actually grows the DNA that you would like to use. Then there's fermentation, which I know that the biotech industry in Korea is very familiar with, and there are many more technologies coming to market where we also definitely need that expertise that the biotech industry in Korea has and can be leveraged to scale this up. And there are various types of fermentation within that, such as precision fermentation that we heard earlier in the presentations today. But the last topic, and that's really the deep dive of the session now, is on plant-based. And we've already heard the official terminology in the sessions earlier. But basically, products that are plant-derived that try to mimic animal-based type of products, such as burgers, milk, and cheese. Now, in general, there are many types of these solutions coming to market. And again, this is not just on the plant-based side, but just to give an indication of timelines within agri-food tech, that we're talking about this today. And I wish we could just all have lunch just 30 minutes ago with all of these solutions already on the table. But unfortunately, that is not the case yet. At least for most of them, it's not scalable yet today. And that's why we need to have these conversations and also actions following today. But to give you an indication of what we can expect to come to market over the coming years, if regulations allow, because that's what we're going to talk about in a bit, you see timelines from short-term to mid-term to longer-term and point them out. I'm not going to talk about it all at this point, but you see, for example, the 3D printing, which can be used via plant-based materials also, where we're going to dive into in a bit. On the timeline of 3 to 5 years, at a scalable level at least. Now, you have the slides, I believe, so you can have more details, and do ask me any questions later on if you would like to dive deeper into any of the non-plant-based focus. But right now, we're going to focus just solely on plant-based alternatives and about the regulations specifically. And as I said, I would love that all of these ingredients or products can come to market immediately. But unfortunately, that is not the case. And that is because we have to check how safe these products are. So there are 2 main questions that you need to ask yourself if you're going to bring any of these products potentially to market. First, has the ingredient or product already been improved in the jurisdiction that you're looking at? So let's take, for example, Korea as a country. And second, is the production technology that you're using to produce this, so to produce the ingredient or to produce the product, and the specific ingredient combined already been improved? Because maybe the product that you're creating with it has already been approved, but this specific technology of how you're producing it is novel, and therefore it cannot be brought to market immediately. Well, if it's both a yes, amazing. Your product is a traditional and authorized food product. And it can be novel food, but it has already been authorized by someone else, or it's just a traditional product and therefore is also already approved and can be brought to market. So, of course, you need to still comply with local regulations, etc., but you can go to market. Well, most of the agri-food tech solutions that we talk about today, unfortunately, are not approved yet, and they are novel food. So you need to gain regulatory approval before you can bring those products to market. And there comes some complexity into this, because even though we've been talking and hearing in the earlier sessions this morning about that ideally we have international standards, unfortunately that is not the case yet today, because these products and technologies and ingredients are so novel that all of the jurisdictions across the globe related to regulations are at the moment trying to figure out what's their standpoint and what's their view on approving these products. And some countries are more advanced in approving them than others, and some are more strict, and others actually welcome these type of innovations quicker to the market. And that's what we're going to see in those differences right now. Hopefully, in 5 or so years from now, this whole conversation is way more standardized than it is today across various jurisdictions. So to dive a bit further into what this novel food means, that basically means that some ingredients or foods are classified by the term novel food, and that's then related to their regulatory standpoint. So that can be the ingredients and the crops. So for example, new sources of crops that you are producing because they have been genetically modified or any other tweaks have been made. It can be new processing technologies, such as, for example, the 3D printing or fermentation that's being used. You can also ferment, for example, certain crops in a way, and then they become novel food as well. And the genetic modifications. So it needs to then be proven that it's safe for consumption before it can be brought to market. And the most important factor basically to consider is what's mentioned on the left side of the slide, that there's no history of consumption before. And the times of whether there was consumption or not depend per jurisdiction, which we will hear about in a bit. But today, as said, there is not even one global novel food regulation yet, let alone that in each and every country there is novel food standards and regulations already. So on this slide you see where there's none, so basically no novel food regulation in a country yet. In some countries it's highly developed, in other countries it is developed. And as you can see in the slide, for example, Korea it's under development. And we see, of course, that it differs also per whether it's cultivated meat or whether it's plant-based, how developed it is. And the US and Singapore are definitely markets where it's highly developed and where they're welcoming quite some of these technologies into the markets. And that's also what you see on this slide particularly. So there is in general the specific countries that we highlighted where we see quite some developments happening on novel foods, or that are critical markets to basically get approval because of the majority of citizens basically that live there and their appeal to these type of products. But their ease of approval is not always as high as in other markets. So you definitely see Europe on the left side having a red indication, and that means that the effort is relatively high to get approval there. And we will dive a bit further into Europe specifically in a bit. The UK, as you know, is currently not falling under the EU novel food laws and general food regulation laws anymore. So they are taking quite some steps at the moment to ease the approval of novel foods, such as the plant-based alternatives. In North America, you see that the US is, well, it's not a green light either, but at least they are welcoming more of these products to the market. Singapore is definitely one of the flagship countries, I would say, to alternative plant-based products. And we will hear a bit more about it soon. And in Australia and New Zealand, you also see developments. But then again, you can not draw one parallel line for one country particular on their total take or view on these type of products. It also depends per type of product, so whether it's, for example, plant-based or molecular farming derived or fermentation derived. Okay, now we're going into some of the details. So I know this is quite some text on the slide, but bear with me, I will talk you through, and we will get to some examples which makes it more practical in a bit. And let's start with the EU, because I said that's the most strict one basically, and long timelines and also the requirements are pretty strict. So overall, if you have a novel food approval process that you would like to go through, expected timeline of 1.5 years to 3 years in total, and then still it might be the case that it's not approved yet. But of course, in Europe, sustainability and health topics are very much known amongst consumers, and that's why many of the companies actually do want to make the effort to ideally get approval into the EU market, because that's definitely one of the more appealing markets at the moment. So in the EU, you must consider a novel food if it's not being consumed before 1997. And you can see basically the data online. There are all sorts of databases from the EFSA, based from the European regulations, where you can see if it's a novel food or not. So first thing you do is just check whether it's novel food or not. If you are going to apply or seek approval for your novel food product, then it's important to bear in mind that some of the dossiers, which include maybe secret information or patents, IP, and all sorts of other information, that ideally you do not want to get that into the competitor hands. But that not everything can be kept confidential. And again, this depends per country. We will see some examples where this is better arranged. But in general, in Europe, the dossier will become public domain, but you can request certain trade secrets, for example, to keep secretly or confidentially, so that your competitors cannot see this. This is also an important consideration for you to take care of along the process, so you can protect your own secrets and your IP. There are, in general, in Europe, always quality requirements, such as HACCP. There are not, per se, other strict or mandatory quality requirements, but of course it depends per country that you need to check. So in general, the novel food is quite a most strict process to go through in Europe. For food specifically. Now there are also other regulations that maybe you need to check if it's a food contact material or food additive. But for the plant-based alternative products, the novel food regulation is the most important to keep in mind. Now in general, so as said before, the lengthy timeline is definitely something to keep in mind, especially because clock stops can be brought in. GMO is not very appealing in Europe, so if there's a way to not have GMO considered into your process, then that's definitely an advantage. And there's strict labeling in general on milk-like and meat-like products, so this might also bring some risk to how you can call your products. I've included also some details on data requirements, etc., which I'm not going to talk through now because of the time, but then you have this type of information in case that's relevant for you, so that you know what kind of data you need to basically hand over. Moving on to the US, where I said that this is definitely a more welcoming country to novel foods. Now, this information is not updated yet to what will happen when Trump will come into, or the Trump's administration will come into play in a few months from now. So we basically don't know yet what effect that will have on any of the regulations. But in general, as of today, there are 2 major routes that you can take in the US for approval. And it depends on whether it's a food additive or an actual food product, which route you have to take. Now, assuming that it's more a food product that you're going to bring to market, we're looking at the left side of the slide, and that's called GRAS. And this is relatively a quick approval, 5 to 9 months in total. And if there's history of use before 1958, then there's no problem. It's not a novel food you can bring to market. If it has not been consumed before that time, you need to apply with the GRAS. And basically you can do the GRAS status in 2 ways. You can either do self-affirmed GRAS, quite a relatively easy process. There is no involvement of the FDA, so this is a quick process, but it might limit your market potential because perhaps not all of the corporates that are here in the audience might be able to actually follow this route because of, well, standards that you have in your company, or it might limit you to work with certain companies in the US that might require actual FDA GRAS status. So the other route is to take not the self-affirmed GRAS status, but the actual GRAS status together with the FDA approved. This is definitely then the most advanced status that you can get for the novel food process. Again, quality requirements must always be taken into account. So the advantage of the GRAS status over, let's say we talked about in Europe just earlier about novel foods, is that in general this is faster approval, it's well market oriented because consumers are looking into future food type of products, and that's what this aims to bring to market. It's way more GMO friendly in general in the US, and the labeling is also more flexible, I would say, in the US than in Europe, but transparency is still, of course, a key component, especially in the plant-based category where consumers are more, more strict and more looking into this. I have some more details, but I already touched upon quite some of it, so I will skip over this because of the time. But looking into Singapore specifically, again, we're also looking into more rapid timelines, 9 to 12 months in total, from pre-submission to actual the novel food approval. And I would say the main difference with Singapore versus the other regions that we just looked into is that it's way more of a collaboration process where you do not have to officially hand it in, and then there's a review, and there's potential clock stops from the government coming in. It's way more of, okay, you need to hand some data over. It's also not as strict as the full dossiers need to be in Europe and into the US. And the regulators really work together with you to make the file, the dossier that you're handing in, as well documented as possible, and that they really have all the data that they would like to see. And in this way, actually, as I said, it's a collaborative process. It makes it way more easier for companies also to work with this because the timelines are just better, therefore the costs are way lower to get things to market. And you might not always actually know what all the regulations want to see from you, and in this way it's way more of an open communication line between the regulators and between you as a company. And also the main advantage of Singapore is that actually there's the whole data will remain private, so there's no release to the public domain. Again, some data for you that you can have a look at, but I do want to still use some time for actual practical examples. So let's talk about an example that actually got approved in the EU, because now I don't want to put EU totally aside for you, like there's nothing that's going to be approved there. There have been products approved under novel food law, otherwise there wouldn't even be this regulation. So plant-based barley protein, for example, is such a ingredient that has been approved, and now you might think, well, barley, nothing novel there, and that is indeed the case. But then again, in the technology that was being used, that's where the novelty comes in. So the technology to process the barley, in this case for AB InBev, together with Evergreen, a spin out from them, to use that into, for example, sports products. In total, this timeline took 3 years to get this approval, so that doesn't even consider any of the R&D and development and innovation type of work, right? The ingredient and the technology should already be established before you're actually going to market. But in November 2020, the request for novel food authorization came in, and the actual risk assessment was only in almost a year later, in 2021. With 2 years later, the scientific opinion coming in from EFSA, and half a year later, again, the actual approval into the EU. So this is to give you an indication of what those timelines actually look like and the type of steps that come in from you as a company potentially, as well as from EFSA, the regulation body in this case. And again, also in this setup, the clock stop actually came in. So this made that the timeline can be extended to whatever time that EFSA needs to evaluate this process. But again, this is not to take you away from EU not being relevant or not being possible at all. It is possible to go to market. Now, I know we have to be mindful of the time, so there are a few other examples, but I won't go through them in detail. I also added one cultivated meat example in Singapore to give you something, a totally different flavor, not just the plant-based alternatives, but also cultivated meat one. But to conclude, basically some of the outlooks, because the topics that I just talked about, that's the current status of today. And as we've heard this morning, for example, from the Korean government, these standards are in continuous development. because not only we should improve the standards itself because there are products coming to market and we learn about them, but also because more and more agri-food tech solutions are being developed every day, such as you will see here in Korea Food Week. And thus we need to continuously be monitoring the market to see what we should improve and which products are safe to be brought to market. And you see that quite a lot of countries are looking into this, and then I'm not only mentioning their traditional countries such as Europe, US, etc., that we just talked about, but for example, countries in the Middle East, such as Saudi Arabia, but the UAE, for example, as well, are also definitely looking into how they can establish themselves as a hub and to advance their food security for their population. So you will see more and more developments in agri-food tech and novel food approvals over the coming years. Of course, that depends on the parliaments also being the rulers at that moment, such as the positive example of the UK and maybe a more negative scenario for the US over the coming years, but that has to be seen. And with that, I would like to end. Sorry for running over. And I welcome any questions if there's time.
That was pretty interesting and really excellent presentation. Thank you very much. 아주 훌륭한 재미있는 발표를 해주셨는데요. 사실 아까 발표에서 말씀하셨던 것처럼 한국은 아직 노벨 푸드에 대한 레귤레이션에 대한 아직 회색 국가로 아까 나왔었는데요. 우리나라에서 아직 확립이 되지 않은 상태에서 이렇게 여러 나라 사례를 소개시켜 주신 건 저희에게 많은 도움이 되리라고 저는 생각이 합니다. 질문을 많으실 거라고 생각하지만 시간 관계상 한 분만 질문을 받도록 하겠습니다. 혹시 질문을 하실 분들은 서서 질문을 해주시면 감사하겠고요. 질문하실 분 있으실까요? 예. 그리고 질문하시는 분한테 스타벅스 기프트 카드가 나간다고 합니다.
매우 훌륭한 발표 잘 들었습니다. 각국의 이제 노블 푸드의 기준들을 설명해 주시면서 언제부터 섭취가 안 되었어야 이제 기준에 적합한지, 또 안전성 평가 기준을 충족하려면 어떤 것들이 들어가야 되는지가 들어와서 굉장히 흥미로웠는데, 노블 푸드 기준 중에 하나인 섭취가 되지 않았다는 점을 어떻게 증빙하는지, 어떤 사례들이 있는지가 좀 궁금합니다. 네.
Yeah, thank you for the question. So actually there are databases that the countries have where that's being listed. And in other cases you can also prove via, for example, scientific evidence that if it's not being consumed yet, but it is approved, for example, under GRAS status in the US, and it's generally being perceived as safe, then you can actually use the GRAS approval system. So it depends a bit per country again. In some countries, in general, there are databases where you can see what's being consumed and therefore what is already being approved. But in other cases, the scientific evidence, and that needs to be strong, of course, also helps to your advantage to get quicker market approval if it is a novel food or a potential novel food. Because, of course, some of the ingredients are just being discovered or rediscovered from centuries ago.
네, 질문이 잘 대답이 되셨으면 좋겠습니다. 혹시 다른 한 분만 더, 한 1, 2분 정도 시간이 더 남은 것 같아서 너무 관심이 많으셔서요. 한 분 정도 더 질문을 받아도 될까요? 하실 분 있으신지요? 없으시면 제가 하나 질문을 드려볼까 하는데요. 방금 제가 슬라이드에서 봤는데 유럽이 3년 정도 걸린다고 이렇게 노벨 푸드를 인정받는 데는 그렇게 말씀을 하셨고, 싱가포르는 아까 닥터 오센이 오시면 제가 물어볼 것 같은데 굉장히 기간이 짧다, 이렇게 나라마다 인증받는 기간이 짧은 곳도 있고 긴 곳도 있는데, 유럽이 그렇게 길거나 싱가포르가 특별히 짧거나 특별한 이유가 있을까요? 제가 프레젠테이션을 주의 깊게 안 들어서 놓쳤을 수도 있는데 혹시 그 이유가 있다면 한번 물어봐도 될까요?
Yes, that is indeed correct. And I would say that in Singapore, they really made it a national important topic to approve novel food products, and not just for the sake of approving novel food products, but to improve their food security, because they are such a small country and they want to produce more foods by themselves, and they cannot do that in the traditional ways. And we might hear a bit more about it shortly. But that is why they are very keen on approving certain technologies to actually advance that and to help them improve the food security, compared to Europe, where there's quite a lot of arable land, there's enough water, there's, well, labor issues, but there's still enough farmers. So very different dynamics, and therefore Europe is less reliant at the moment, but not if we would have a more future-looking vision on those kind of novel technologies, and why Europe can dare to be, well, in my opinion, being behind. But with the new EU Parliament that is just being in position as of this week, I believe, actually there is more focus on innovation, and we will expect to see changes in novel foods over the coming 5 years. I don't want to put a specific timeline on that because no one knows at the moment, but we will see advancements in EU novel food as well.
네, 너무 훌륭한 답변 감사드립니다. 다시 한번 그 연사분께 큰 박수로 인사를 드렸으면 좋겠습니다. Thank you very much. We really appreciate that. 자, 제가 저 좌장이 나서서 시간을 좀 끌어서 정말 죄송한데요. 자, 두 번째 연사분을 소개시켜 드리도록 하겠습니다. Dr. 라파엘 오센이시고요. 지금 현재 싱가포르 식품 바이오테크놀로지 이노베이션 연구소의 식품공정 기술 부서장으로 계십니다. 아까 제가 점심 때 같이 식사를 잠시 하면서 여쭤봤는데, 원래 독일에서 태어나셨고요. 그리고 독일에서 학위를 받으시고 지금 싱가포르 연구소에서 아주 재미있는 연구를 하고 계십니다. 오늘 발표하실 주제는 Enhancing the Nutritional Value of Plant-Based Alternative Foods for Asian Consumers라고 이렇게 주제로 얘기를 해주실 건데요. 여기 이제 저희가 에이시안이 굉장히 많이 있습니다. 그래서 저희 모두에게 아주 도움이 되는 그런 좋은 프레젠테이션이 될 거라고 생각합니다. 여러분 큰 박수로 닥터 오생 박사님 맞아주시기 바랍니다.
Thank you very much for the kind introduction, and thank you for also the organizers for inviting me here to this great event. And it's my great pleasure to speak to you at the Global Symposium on Standardization in Food Technology. So today I'm going to be covering basically 4 main topics. I'm going to be starting about the Singapore approach to future foods. I'm glad I added this to this talk after the prelude that I already got. Then I'm going to be talking a bit about plant-based alternative foods, and being a food technologist, I'm going to be touching a bit on ingredients and on processing, not too much, I promise you, and then continue to talk about nutritional quality of plant-based meat, giving a bit of background, as well as then some current research findings and future outlooks. And I think I'm going to have 20 minutes, is it? So I'm going to need to be quick.
Doesn't really have to be.
Okay, all right, got it.
We are not going to pay any money for that, okay?
Okay, thanks. All right, so in contrast to South Korea, Singapore is a really small country which relies heavily on food imports. In fact, more than 90% is currently imported from overseas. And this makes Singapore vulnerable to global crises like climate change, geopolitical tensions, and supply chain disruptions. So hence, Singapore is very actively looking for ways to increase food security by building up capacity as well as capabilities in future food production. So to strengthen food security, the Singapore Food Agency, in short SFA, is pursuing 3 broad strategies called the 3 food baskets. To support these activities, the Singapore Food Story R&D program was initiated a couple of years back in order to support the national agenda of achieving its 30 by 30 goals, which is to produce 30% of Singapore's nutritional needs sustainably and locally by 2030. So this program covers 4 main areas, of which alternative proteins for future foods plays a pivotal role, and plant proteins are part of it. Now, as Singapore is limited in terms of arable land, its focus is more on building capabilities in biomanufacturing, as well as in cultivated meat of alternative proteins. However, it's recognized that plant proteins will be complementary protein sources in foods to bring down costs and to make it more nutritional and available. And on the right side of the slide here, you can see the regulatory framework, which we heard about before. And indeed, Singapore is really doing a great job in being very quick. So Singapore is one of the few countries where you can actually go to a butcher and you can buy cultivated meat already. I've done it, and it is really great that this is already happening. Now, the R&D, let's say, ecosystem in Singapore consists of both universities. These are under the Ministry of Education, and the mandate is to generate a knowledge and basic understanding of, of how food works. The other research players are under the Ministry of Trade and Economics, and A-STAR is a part of it. A-STAR stands for the Agency of Science and Technology, and it's a bit similar to the Fraunhofer model in Germany that really focuses on applied research. It has about 6,000 staff in total. And one of the recent institutes out of 20 that was formed was the Singapore Institute of Food and Biotech Innovation. This is the institution that I represent today. So the institute has about 200 staff, and this shows Singapore's dedication in really driving food innovation because it initiated an own institute for that. As you can see, the focus of the capabilities of the Institute are centered around discovery and biotechnology, aiming towards new ingredients based on precision fermentation, for example, and also, I would say, more traditional food science and processing, where then we look into how can we take these ingredients and how can we structure these into delicious, palatable foods. For that, we need our colleagues in the sensory and oral processing, as well as then in our nutrition department, looking into the nutritional quality, and that's what I'm going to be focusing on in my talk today. Now, from all alternative protein sources, plant proteins have been used the longest time, right? At least that's how it seems. Well, in fact, if we look at it more closely, we are still at an early stage if we compare it, for example, to other industries like the dairy industry. So to me, it's always compelling that in the dairy field, they are able to turn one raw material, which is cow milk, into a wide range of food such as butter, cream, yogurt, and cheese. They have also developed a great understanding of how milk protein can be broken down into specific fractions, so they can now offer more than 10 specific protein fractions with specific functionalities tailored to food applications, also for nutritional outcomes. So for plant proteins, we are still very far from that understanding. If you look at plant proteins until now, the market is still dominated by soy, wheat, and pea. And in fact, these proteins are actually byproducts. You could also call them side streams, and we're going to hear later about side stream and upcycling from in later presentations. Side streams from byproducts from either soybean oil, or wheat starch production, and so they have been at best used for feed up until 20 to 10 years ago, and just recently they have been used as ingredients for food due to the demand. Now, besides these crops, there's also now more research into other crops from different regions, legumes, seed proteins, or cereal proteins. What is the key, let's say, parameter for protein ingredients? The quality really includes many parameters like taste, nutritional quality, availability, and cost. And here on the left side, you can see some choice parameters for food developers to then choose the appropriate protein source. On the left side, there is a selection of parameters that are relevant for choosing suitable protein ingredients for food applications. This is a nice overview here made by the Good Food Institute, and it lists down basically different ingredient sources and then does some characteristics on in a simple color coding way. So what are the factors that affect these key parameters besides the raw material source? So this includes the agricultural side, obviously, so which crop varieties are used, where are they grown, under what climate and soil conditions are they grown, and the post-harvest treatment. But another major factor is the processing, so turning these agricultural crops actually into food ingredients. So the flow chart here, again from the Good Food Institute, shows the main processing steps to turn soy or pea into protein powders. And these include basically milling, oil extraction, and protein extraction. So all of these processing steps, they do affect the characteristics of the final protein ingredient. And we are still far away from really understanding the effects, let's say, of drying, of extraction, of heating on really the functionality, on the taste, and as well as on the nutritional properties of these ingredients. So now we have in the market, let's say, one soy protein isolate, but still there are changes batch to batch, and this is not a one-size-fits-all, and I think in the future there is a huge opportunity to develop more ingredients with more targeted functionalities for the specific markets. Now, usually we do not consume the powders by themselves. We want to have them included into tasty food products. So one major opportunity of plant-based proteins is actually the potential to complement animal protein. And I say complement here because I really did enjoy lunch today. That was a beautiful meat that I really enjoyed. So it's not necessarily about replacement. It can also be about complementing. And why do we need to do that? Because we all know that although it is, for some of us, meat is very delicious, it does have really a lot of negative impacts on the environment. You're all aware of this. So that's really the motivation and the opportunity here. So in order to formulate foods with similar properties to animal foods, or like meat or seafood, we need to create similar consumer experience in terms of taste, texture, and appearance. So this requires processing strategies to form muscle meat-like structures, and we have yet started to really explore the effects on the food quality. Now, this is really my major topic, but I will resist the urge to talk more about this because the previous speaker will go more into this. Bottom line here is there are structuring methods available, and these are already on the market, but I would dare to say that we do not really know so much about or enough about the impacts on the nutritional value of this processing. Which leads me now to the nutritional part of it. So the reason for consuming plant-based meat products in Asia is really shown here. So this is the consumption drivers across markets and demographics, and you can see that health, which is the black bar, is really by far the most common plant meat consumption driver. So there is a mandate from the consumer to really look into this and to develop and to deliver on that. And I think this shows that there is a demand for evidence-based R&D into nutritional quality of plant-based meats that goes beyond just marketing. If we look at protein digestion and health outcomes, so on the left side, put very simply, when we consume foods, in the oral cavity, we're breaking it down, then this goes through our digestive system, and to make it short, the proteins are broken down into amino acids that then go into the bloodstream, and then they are available for building our muscle or for doing some other bodily functions. I will not go into detail on that. Proteins are highly complex, so you can see here the build-up of proteins. It all starts with the amino acids, and depending on the amino acid, let's say, sequence, then this forms specific foldings, which then lead to tertiary and quaternary structures. So it's not only about the amino acid sequence, but it's also about the three-dimensional structure of these proteins. When it comes to defining the protein quality in the frame of nutrition, there are several terminologies, and probably the most important is bioavailability, which refers to the fraction of the amino acids in an ingested protein that are actually absorbed in the body and that then can allow the metabolic availability, right? Protein quality is only the capacity of a protein to meet the indispensable amino acid requirements of an individual. And I'm going to be talking a bit about that moving forward. Why to study proteins? Why are they so unique? Well, amino acids are proteins are part of the macro nutrients in foods, but the difference to, let's say, carbs or lipids is that there is no storage system. So we need to have a constant influx of amino acids and of proteins in order to then do our bodily function. So that's why it is unique. How do we define protein quality? Well, one is the amino acids. It's the amount of amino acids, but it's also the proportion of amino acids. And you can see here on the bottom left a table that gives the recommended amino acid scoring pattern for different age groups, because this changes over time while we are aging. And it lists down the 9 essential or indispensable amino acids. We heard about this already in the presentation this morning. And I like to look at this graph here of the Liebig barrel, which kind of illustrates the importance of the limiting amino acids. It says that if there's one amino acid limiting, in that case methionine, then all the others, they can also not be absorbed. So you need to ensure that you do not have a lack of an amino acid. Okay, how do we, let's say, analyze then the protein, the protein quality? And here there are different ways to do that. One is by in vivo digestion assays, so basically doing clinical trials with blood analysis, with tracer methods. So you can imagine that this is more time consuming and costly. It involves human participants. So therefore there is a lot of work going into developing in vitro digestion assays that simulate then the human digestive system. On the left side here, there is some data on the static models. The InfoGest is probably the most prominent one. On the right side, some examples of dynamic models. There's the TIMS model or the Shimes model that then actually have they replicate the human digestive system, including then the bowel movement, including the dynamic changes of pH and of temperature. So it's more sophisticated. It depends on really what is the target of the study. Then in order to have a number to give a quality index to a protein, there are different methods also that we heard today already, the DIAS or PDCAS, and in the interest of time, I'm going to skip that. There is some work on studying the influence of food processing and preparation on protein quality. And the way that food is processed and prepared does really significantly impact the quality, digestibility, and nutritional value. Some are positive, some are negative. For positive effects, it can improve digestibility. An example is cooking of meat or cooking of eggs. This changes the protein structure. They get better access to the enzymes, and then we can absorb them better. Another one is we can kill the pathogens, which we don't want to have. And then inactivation of antinutrients. Today I very much enjoyed the kimchi that I had. This is a good example of how fermentation can improve the digestibility and reduce some of the antinutrients. But usually Paracelsus, the dose is the poison. There are also negative impacts. Too much heating can cause heat damage, can cause loss of amino acids via Maillard reactions, or formation of harmful components, for example, during high heat grilling. So we need to look more into that and really get the data that support and the suggestions of how to do the right food processing, specifically for new food categories such as cultivated fermentation or plant-based. So this is a quick comparison of animal-based and plant proteins. I think this will be shared also in this is in the slides. So I'm going to just be quick and jump to the research findings and future outlooks. So this is now a study that we did about three to 4 years ago that was started. So that was really during the hype of plant-based foods. A lot of companies came on the market and they all claimed that they are better than animal food, than animal meat. So the objective of this study was really to investigate, or we asked the question, are they really healthier than animal meat? What are the numbers, what are the clinical data that support that? So the objective here was to investigate the impacts of dietary patterns comparing plant-based meat analogs with animal-based meats regarding cardiometabolic health among males and females in Singapore, looking specifically at the elevated participants with elevated risk of type 2 diabetes, because this is really an issue in Singapore. You can see the study design here. So the participants, they were instructed to have either an animal-based or a plant-based meat diet. This was a study over 8 weeks. And then you can see on the top left the samples the food that was offered. It was plant-based meats that are commercially available, as well as commercially available animal-based meats. And then the study looked at several health outcomes such as cholesterol, such as glucose, as well as then blood pressure and several other metrics. So the first outcome of the study was that the team did not really see a widespread cardiometabolic health benefit of plant-based meat compared with the corresponding meat diet. And that was a bit against the hypothesis, because we thought in the beginning that having plant-based meat, which uses more polyunsaturated fats compared to saturated fats in meat, this would have a beneficial effect on the LDL blood level, but we did not see that in the data. The second finding was, and that's a bit more specific here, we looked at the glycemic regulation, which is a risk indicator for type 2 diabetes. So if you look at the graph on the bottom left, it shows basically the blood sugar level that was monitored by finger pricking over a time of 24 hours. And what you generally want is you want to have a flat curve, because that means that you do not have any blood sugar spikes. We did see in this data that the plant-based meats resulted actually in higher blood glucose spikes. So this refers to a longer time the blood glucose is out of range, which can be a factor for people with type 2 diabetes, or with that are at the risk of type 2 diabetes. So what does this mean? The blood glucose spikes, they are most attributed to higher carbohydrates in the plant-based meats. The carbohydrates, they come from starches, fibers, or other texturizing agents that help to stabilize the matrix. So the implication here is that we need to develop more knowledge and more processing strategies in order to then structure proteins without having to use these stabilizing agents, so that we do not have this effect that comes here from the carbohydrates, because animal-based meats usually does not contain any carbohydrates as well, as long as they're not formulated into burgers or so. The second data that they found was they looked at the nocturnal blood pressure dipping, which is another independent risk factor for cardiovascular diseases. And what you want is you want to have a dip in your blood pressure overnight in order to then have a more relaxation for your arteries and so on. So what was seen here is that the plant-based meats showed a reduction in the nocturnal blood pressure dipping, which is associated with the increased arterial stiffness index. So, in short, the negative effect may be attributed to the high sodium content in the formulated plant-based meat products. Why do they have more sodium? Usually because they needed to mask some off flavors of the beany, grassy, green notes in many of these plant-based alternatives. So there is an opportunity, if we can improve the taste and flavor, and if you can find strategies how to reduce the unwanted off flavors, we will then have the opportunity to reduce some of the salt in the final product and then improve it in that space. So in summary, the assumptions of a health benefit that was claimed by many companies for consuming a plant-based meat analog, because it was shown that plant-based general diets are beneficial, cannot be that easily made. So this creates really opportunities and stimulus for the food industry to reevaluate their production and to not only look at taste and texture, but also to include then the nutritional profile. And I think if we look at the developments, the rapid developments in this space, it's also clear that this takes time, but now it's the time really to look into this. And this is my last example. So this is a research study that we are just about to finish. And this was about taking some of that learnings that we had and then bringing that into a new, and applying that for better products. So the aim here really was to optimize consumer acceptance and the nutritional quality of plant-based meats. So first, in the work package 1, we looked at upstream processing, so basically taking ingredients and then structuring those in work package 2 into structured meat alternatives via high moisture extrusion, which we're going to hear later in another talk. And then we did clinical trials and got some health data based on these prototypes that we have developed with the team in-house. So the first work that we did is we looked into complementary proteins to improve the amino acid availability. So think of this Liebig barrel, right? We want to reduce improve the amino acid profile by having less of the limited amino acids. So here we did some mathematical optimization, some computational work, and we calculated based on several input parameters here from different raw materials, different formulations which were different blends basically of commercially available plant-based proteins, and then we extruded those into textured protein, and then we used these textured proteins to formulate these into typical Asian food formats. So these were sumai, nonghya, gyoza, and langshan meat. If you have not tried them yourself, come to Singapore and then try them. We then looked at, we evaluated and compared the nutritional quality, postprandial satiety, and other metrics with the animal-based counterparts. The study design you see here on the top right, and then the analysis plan on the bottom. So we looked at consumer acceptance, appetite, satiety, gut hormones, protein metabolism in this case, and glycemic response and proteomic analysis. And our hypothesis was, with combining different plant-based sources, we can improve the amino acid profile. So now let me just walk you quickly through the findings. Now you see on the bottom, you see the comparable amino acid availability, and what we found was that in fact the mathematical optimization and our blending approach really resulted in food prototypes that resulted in comparable amino acid availability in the blood, postprandial amino acid availability compared to the animal-based products. And this is very interesting because we also did extrusion of these plant-based proteins. So it seems like the extrusion did not reduce significantly the amino acid availability. So a very promising finding. Next one, again we looked at the blood glucose response. And in comparison to the previous finding here, you can see that on the graph on the top, that the plant-based siumai and nonghya actually had a less glycemic response compared to the animal-based formulated version. So in that case, if you are having some issues with type 2 diabetes, that will be the preferred choice for you. So it showed that by formulation, we can actually improve that. So less carbs used in plant-based versions are beneficial for that purpose. Now the last part is about the palatability and the overall acceptance of the meals. And you can develop the most healthy food, but in the end, if it's not delicious and if people are not choosing that one over the animal-based version, then you don't have that health benefit. And so here you can see the results from that study. We looked at visual appeal, smell, taste, aftertaste, and overall acceptability. And you can see here on the left the images of the prototypes that the team has developed. And in fact, we found a better sensory perception and acceptability of the plant-based prototypes compared to the animal-based commercial benchmarks. Now, in all fairness, I want to also point out here that that the benchmark were formulated products, luncheon meat, gyoza, siumai. These are not your bulgogi or your galbi cuts. This is maybe easier to achieve, but I think it is a good start. And with that, I come to the summary and future outlooks. So we talked a bit about the current gaps. Limited range and understanding of plant protein sources, ingredients processing focused still on yield instead of functionality and nutrition. Then the current processed plant-based meats are still high in sodium fat stabilizers because there's still limited experience of how to formulate those and these raw materials into palatable foods, and limited understanding of the processing effects of these new plant-based foods, specifically also including fermentation and cultivated cells, and the health outcomes for Asian phenotypes. And that is also something to point out. What is healthy for me may not be healthy for you, so we all have different reactions to the foods that we are consuming. This goes with opportunities, mild processing approaches, during protein separation and food structuring to retain more of the beneficial micronutrients. I haven't talked about that at all, but there are also benefits in micronutrients in plants. Redesigning food processing to improve nutrient release, taste, and flavor. Here we like to think about the food structure concept, that we need to develop a specific food structure, a three-dimensional network with specific release properties for nutrients, and then holding mechanisms for the unwanted, let's say, off-flavors in these foods. And then there is a big, I think, opportunity in combining traditional fermentation methods and the knowledge also that is in Korea, specifically in that field, and biomanufacturing like precision fermentation, cell-based meat with plant proteins. So Animal foods, this is also used. They are they are fermented. They are cured. We don't do all of that in plant proteins, in plant-based meats yet, but I think we should, and I think this would also improve then the taste and the quality of these foods. I would just, as a last slide here, point to the new food sources and production system foresight report that was just published by the FAO. I was very privileged in being involved in that team about a year ago, where we met in Rome and we discussed many of the regulatory aspects, the health aspects, and also the nutritional aspects of plant-based meat, precision fermentation, and 3D printing. So all of these materials are publicly available. So I suggest that as a good read. And with that, I would like to acknowledge the team that was doing all of this work, and I would like to thank you for your attention, and I'm happy to take any questions you may have. Thank you.
네, 아시아 소비자들에게 필요한 단백질 영양을 어떻게 측정하는지, 그리고 이제 여러 연구 실험 데이터를 통해서 우리에게 좋은 실험 결과를 보여주셨는데요. 너무 재미있는 발표시긴 하지만 지금 시간이 많이 지연이 돼서 질문은 한 분만 받도록 하겠습니다. 예, 일어서서 질문해 주시면 감사드리겠습니다.
네, 좋은 강의 감사드립니다. 그 두 가지 궁금한 점이 있는데, 첫 번째는 그 프로틴 펑셔널리티에 대한 부분입니다. 그 아까 한계에서 이제 프로틴 펑션에 대한 것들을 우리가 잘 모른다라고 얘기를 했는데, 그 어떤 펑셔널리티가 저희가 얘기하는 그 미래 세대의 식물성 식품을 만들 때 도움이 가장 될지, 어떤 것들이 우리가 정말 알아봐야 될 것이며, 그리고 그러한 DB들을 어떤 식으로 쌓을 수 있을지에 대한 질문이 첫 번째고요. 두 번째는 익스트루전이 지금까지는 이제 가장 최신화되고 가장 상업화할 수 있는 방법이라고 보는데, 그 여전히 익스트루전 자체가 가지고 있는 문제점이나 혹은 이걸 개선하기 위한 다음 세대의 기술의 실마리는 어떤 것들이 있을지 두 가지 질문드립니다.
Thank you very much for your two questions. Very good ones. So for the first one, functionality. I think functionality is a term that, first of all, you would need to define. There are different definitions. Probably techno-functionality is the one that we are referring to, meaning that what is the technological functionality of a protein in a food matrix. This can be emulsifying, this can be foam building, this can be gelling. And you are absolutely right that these are very critical and very important factors. And I think with looking more into different crop varieties, on the agricultural side, how can we affect the protein structure to then define or to generate a specific functionality? This is not done yet at all, because right now it's just about the yield and mainly on the yield of the primary outcome. So I think this is one aspect that we should look more into. The second one is then the processing, as I mentioned. There is really a huge difference whether you use, for example, a pH-driven wet extraction or whether you use a salt-induced protein extraction. You get totally different functionalities. One is a highly soluble protein if you take care of the temperature damage. Another one can be almost a fat-like, micellular structure that then can be used as an emulsifying or as a fat substitute. So I think agricultural side is one aspect, and it's the processing, and then of course it's also the availability of different crops. And the more we learn about new crops, mung bean is an example, right? The company Just that used this as an egg replacer, they found this great functionality of gelling of the mung bean, and I think there is much more available and there's much more to explore in terms of new proteins that give you specific functionalities. And then we also always need to look at taste and texture. So we also can think of dry fractionation, for example, not necessarily going into a protein isolate, but going for functional protein fractions. And by a functional protein fraction, we may be able to leverage the protein component as well as then the fiber that may be attached to this, or the starch that is remaining here. So I think this is another important approach. Now, the second part of the question is about extrusion and the limitations of extrusion and how can this be further improved. And also here, I don't want to talk too much about that yet because this is the topic of the talk later. Just my two cents is, yes, extrusion is one way, and I think we can do, it's still very simple. We just have this one big cooling die, which is basically a double-walled, cylinder. There we can look into different geometries. We need to understand the flow profile better. We need to understand the solidification better of the different raw materials that we are extruding. I think extruded design is one way to go. But then this may not be the only technology. There are other mild processing means, shear structuring. There's the shear cell technology. There is, we heard about 3D printing. Freeze structuring is another way. And I think in moving forward, really the opportunity is in taking the best out of the different protein classes, whether it's fermentation, it's cell, or whether it's plant, combine those, and the same thing for the structuring methods. I don't think there's a one-size-fits-all. I think extrusion works for some products, for some it may not work. For maybe seafood, we need a different structuring method. So I think it is, it's still very, the space is really open, and I think I'm really looking forward to the improvements that will be made in the future.
네, 발표에 저 질문에 답변이 너무 잘 해주셔가지고요. 사실은 저도 너무 오늘 좌장이긴 하지만 연구가 너무 재미있고 한 2시간 정도 더 질문하고 토론하고 싶은데 지금 시간 관계상 오늘 여기서 마치도록 하고 일단 이 세션이 끝나고 나서 15분 휴식 시간이 있습니다. 그때 혹시 올젠 박사님한테 질문하시고 싶은 내용이 있으면 그때 개인적으로 가셔서 하시면 될 것 같습니다. 오늘 너무나도 훌륭한 발표를 해주시고 멀리 싱가포르에서 오셨고요. 한국의 2번째 방문이신데 벌써 한국 음식하고 완전히 사랑에 빠지신 우리 올젠 박사님한테 큰 박수로 감사를 드렸으면 좋겠습니다. Thank you very much. 자, 드디어 오늘 2번째 세션의 마지막 연사이신 한정훈 박사님을 모시도록 하겠습니다. 한정훈 박사님은 지금 현재 미국 언리미티드라는 언리미티드 INC인가요? 언리미티드 INC라는 회사의 기술 총괄로 계시고요. 미국에서 아주 오래 사셨다고 아까 좀 전에 말씀을 하셨는데 한국 분이십니다. 한국 분이시고 한국말도 잘하시는데 오늘 발표는 영어로 하신다고 하는데요. 이따가 질문하실 때는 한국말로 하셔도 될 것 같습니다. 지금 오늘 발표해 주실 내용은 Technical Trend and Regulatory Status of High Moisture Extrusion in the US라고 제목인데요. 아까 고수분압출성형 기술에 대해서 청중들에게서 질문이 많이 나오는데 오늘 아주 재미있는 발표 내용이라고 생각됩니다. 여러분 한정훈 박사님께 큰 박수로 환영을 해주시기 바랍니다.
Thank you for inviting me. And currently I'm working for Unlimit, which is actually plant-based meat company. But before I joined Unlimit, I was an R&D senior director of Good Meat and Eat Just. So previous speakers are talking about plant-based egg and also cellular cultivated chicken. So today my topic is about high moisture extrusion, but basically I would like to cover this technology to extend to the usage of plant-based proteins and the technology and what kind of regulatory framework we should think about for this technology. Yeah, this slide shows the currently available the plant-based meat from all the way the early stage of late 19th century from Dr. Kellogg and all the way down to the 2022. This is what you can see is many of this company used to be a small company, But right now, they are acquired by the big companies, such as Kellogg has Morningstar Farms, and Maple Leaf Food as Field Roast and Light Life, and Nestle has Awesome Burger, Sweet Earth. So now you could see a lot of global big companies. They are actually coming into this small size of business, which is a plant-based meat business, and now this business is getting globalized by the control of global companies. Okay, you could see the current big player in this area in the U.S. The headquarter address is some company has address in the U.S. and some are in Canada, but they are working their business in the U.S. market. So such as Beyond, Field Roast, The Garden, Impossible, Light Life, and Morningstar, and Quan and Edie's Veggie Cuisine, and they are all doing their business in the U.S. market. So U.S. market is the biggest market for this plant-based meat business. Okay, you could see the very interesting chart. On left side is actually regular CPG companies. They invest a lot of money for the plant-based meat. However, right side, 5 companies, they actually huge, global, huge meat company. They also invest their money and resources for this plant-based meat business. All right, this is a strategy for how could make a very nice and delicious, high-quality plant-based meat. This is actually basic fundamental strategy for my company currently. However, this can be shared together with you because this is not only for my company's strategy, this is everybody's strategy. So first, what is the goal? That is, let's make a great, high-quality plant-based meat product. All right, and what is the objectives? Number 1, muscle fiber formation, obviously. Second, meat flavor. Third, lipid layer and color. How? You have R&D strategy in there. Okay? So if you see basically, if you dissect all of strategy and goals, and it's very common languages. Problem is whether your company or your research lab is capable to do all of these every R&D strategies at the same time. Maybe not. So what do we need right now? We need collaboration. We need to work together with big company or make some kind of research consortium together between the small companies. All right. Before I jump into the final product quality, I would like to introduce some kind of very interesting research. What I did, I collect very high quality beef patty from high quality to the very low quality of beef patty. And the other one is chicken breast meat. So I think I collect nearly 50 different versions, and then we do the pre-screening, and finally we do the blind test with our sensory panelists. Finally, after I collect a whole of data is very simple. I ask only 4 questions. First question is, what is your preference, acceptance of appearance? Second question was flavor acceptance. Third one was texture acceptance. And fourth one is, what is your overall acceptance? Simply 4 questions. So, simply, why equals to function of A, the appearance and flavor and texture scores. And I normalize all the data. I do the regression analysis and compare the parameter of each variables. What happened? In the case of beef patty, yes, 60% of weight go to the texture, and 30 goes to flavor. So texture is twice more important than flavor for the case of beef patty. If you have a limited amount of money, research grant, or budget, or people, how do you assign your project? Simply, yes, texture is first for the beef patty. But chicken breast is different, 40-40. flavor and texture are equally important for the overall acceptance. I don't know how many companies they set up the research plan based on this kind of analysis first. This chart clearly shows that how we spent our money and our time and our resources for the research and development. Okay, first one is flavor. We do a lot of flavor. This is actually a real example I did for the good meat. Upstream team actually harvested a lot of chicken cells and tissues, and they brought that one to me. And I actually analyzed the quality, and finally I made the final product. I do the sensory analysis. So I try to correlate the sensory result of cultivated meat with the cultivated cell properties. So I found what is a very important thing, and then this is very nice guideline for upstream the cell biologist. The reason is, what is the goal of a cellular cultured meat? And same, what is the goal of a plant-based meat industry? To make a human food, right? Therefore, food scientists' role and function and leadership is very important. But if you have a job in the cultivated meat, still same in Korea, we have a lot, near more than 10 companies currently working in Korea for the cellular cultivated meat. How many food scientists are involved in their company's R&D team, in their leadership team? If their leadership team is still consists of cell biologists, then they are far behind. Because we are currently trying to make a human food. Therefore, food scientist leadership for this kind of cultivated meat and plant-based meat is very critical. Okay, flavor profiling. Yes, flavor is very important because we cannot use any kind of meat flavor, real meat origin flavors. We should use some kind of flavor which is plant-based flavor. So first, real chicken meat flavor profiling is very important. Generally, whenever we said profiling, we just think of this kind of spider web type of profiling. Yes, that's important. However, another most important thing is chewing time. Initial kick, spiking of a flavor, reaction flavor, or a middle time, or final time, those are profiled. Should be profiled well, and then we could design the total profile of the flavors. All right, the last one shows very interesting thing. Obviously, we like a long-lasting umami and reaction flavor for spiking, and we should use a natural extract of ingredient. We should blend everything to make a meat flavor. But we also should use AI and big data. The reason is, recently, NATCO, which is a plant-based, the beverage company, they published a very interesting, result through the scientific article. They say that milk flavor can be achieved by the mixture of pineapple and the cabbage. Have you ever think about that kind of solution before? Even you are really out-of-the-box type of person. No way, scientists cannot do this way because it's too much out-of-the-box. How could we assume that milk flavor can be achieved by the mixture of pineapple and cabbage? It's too far away, right? But AI, big data, they don't care. They are limitless. So finally, we got this data. This is great example. How could we utilize the AI and big data to get the better solution for the flavor? Okay, this is actually texture. All right, so juiciness is a very important parameter for any kind of meat. But if I ask you, what is the juiciness? Juicy, Yes. Then if I ask what is opposite meaning of juiciness? Dryness? Yes. But juiciness is about juice. It's not about water. It is about liquid. So opposite meaning, well, dryness is opposite meaning, yes, that's true. But juiciness contains is related to some amount of total liquid, including water and oil. But interestingly, another meaning of juiciness, what I figured out from this descriptive analysis, that was toughness. Yes, toughness is opposite meaning of juiciness. Okay, it's understandable. It's not about dryness, but it's tough. It's completely opposite meaning of juiciness. Yeah, understandable. And however, toughness is also opposite meaning of tenderness. But tenderness and juiciness is not same meaning. So after I checked all of correlation between this terminology and terminology, I could extract out just 3 most important parameter, that is juiciness, firmness, and chewiness. I'm showing some kind of example. How could we get some kind of very nice scorecard to evaluate our intermediate samples quantitatively? All right. The next topic is how could we create a 3D structure? Yes, steak. Yeah, it has a muscle fiber. It has a fat, connective tissues. How could we create all of this one? Salmon, yes, it has a multiple structure too. Okay, this is the example, what I did when I was working good meat. The first one, the picture on the chicken nugget picture is just a mixture, and just make a mold and press it. So this is very simple. The right side, the top one, that skewed one, that is actually the first version using the high moisture extrusion, which is actually 1 inch of width and 1/4 inch of thickness. It's very narrow and thin strip. Third one is actually 3 inch of width and 1 inch of thickness. It's quite a big, steak size. And the last one is another thing. I modified this one to have more fibers. Yes. Now I would like to talk about high moisture extrusion. Yes, this is extruder. But extruder is a very interesting tool for the engineers or food scientists. If many of you actually the background of food science, let's think about the protein structure first. Okay, when the protein is fed into the machine, it is actually generally it's just a native form. But this protein is generally denatured, generally heat denatured or shear denatured, and then it goes to the one directional orientation. And after that, when it is coming out from the extruder, at that time it's a kind of a liquid structure. And inside of cooling die, it actually fixes its own structure. So they made some kind of cross link between the molecule and molecule. That is chemistry. So if you would like to run your extruder very well, first thing, you should well known about protein chemistry and denaturation and refolding, unfolding, whatever protein chemistry expert. That's very important knowledge we should know. generally, in the case of high moisture extrusion, many people are quite used to use the extruder part, but not a lot of people are familiar with this cooling die concept. Cooling die is actually long, the cooling machine in the part, and the liquid shape of flowable molten protein is coming up from the extruder, and it actually hit the very cold surface, and it turned to the solid, right? However, middle part of this extrudate is still liquid, so they move faster than the surface. Therefore, it generally forms some kind of parabolic, patterns, because core is faster than the outside. That's why generally we have a pattern of that parabolic shape of the pattern. But generally, cooling die is not a fiber forming the machine part. Cooling die is designed for creating the layers, not the fiber. You see, the great example. How does it look like when the product is coming up from the cooling die? However, nobody wants this kind of very, thin and narrow strip. We want some steak type of, product. So if you make the cooling die as big, we have more problem. Generally, heat from the surface to the core, that temperature gradient. I'm not talking about temperature gradient of the initial part of the cooling die and the end of cooling die. I'm talking about surface and core gradient. That's very critical. However, this dimension is really thick dimension. So we need more time to cool down the core part. So you have more problem of this parabolic issue and layering issue. Another thing is, if I say the mass flow rate is not going to change. However, volumetric flow rate will be changed because outside area is larger, cross-sectional area is larger than the small cooling die. This big die has a bigger, surface, cross-sectional area. Therefore, volumetric flow rate, that means the velocity is way slower than in the case of a big wide cooling die compared with a small narrow cooling die. That makes a problem too. So this is example. So what happened? They made some kind of zigzag pattern always. If you use a bigger size of a cooling die, wide cooling die, they made a zigzag pattern. So we need something in between them. That is what I said, the Reynolds number controlling system. Reynolds number, that is actually the first, the lecture of, food engineering and chemical engineering, Reynolds number control. We need to make a, laminar flow and continue this laminar flow until this material is cooled down. Otherwise, no way to make, the fiber. Or, why cooling die? We may stretch all of this one because this is very common technology in fabric industry. Yes, I tested it. Yes, it works. Coming out like a little strip, and I stretch. Finally, I got some kind of bundle of fiber. And if you see the inside, they have a very teeny tiny micrometer size of fibers. I'm gonna skip this part because the main message of this one is very last one. Meat has a multi-phase system, so we should use co-extrusion system to make a multi-structure. Okay, overall acceptability is very important because appearance, flavor, texture, they are very important. Okay, overall overallly, first column on the left side is about the dry TVP. We use, regular extruder and make a dry TVP, and they utilize the dry TVP for texturizing, raw material. But, right now, that is what I said, the first generation plant-based meat. Now we should jump in the second generation plant-based meat. That is, we should utilize the high moisture extrusion with this is multi-phase system, which is lipid gel structure optimization. After we combine those two, we may make a very nice next generation plant-based meat very well. All right. All about this one is regulation, but please read the program book, and it says it has all the information about what kind of regulation will be applied for this plant-based meat. Generally, this is my conclusion. In the US, federal government control plant-based meat industry and their product without any specific regulatory framework because they're just food. They use regular food, regulation. They consider the plant-based meat product a conventional processed food product and manage them legally as current and effective FDA and USDA regulations and policies. Why? For the purpose of no misbranding of them from traditional meat and poultry product standard without causing any confusion of the standard of identity. This is very important, right? So if you ask me what kind of a standard should be applied for the plant-based meat, right now, I would say probably the safety, we have, the food safety regulation already. CCP, it's the same. What is the difference? Standard of identity. We don't have a lot of identity. The name, how could you label this one? That is based on the standard of identity, legally. We need a legal name. That's why, the first step is standard of identity. I think many of you already understand what I'm talking about. We don't need a lot of regulatory things to standard. First thing first, identity first. And some US state and Midwest region of which the major industry is cattle farming and meat processing industry, they try to differentiate the plant-based meat from traditional meat using their state legislation and precedent. Yes, but this is not all the case of the United States. This is only 5 or 6 states in the Midwest area, and they have a regulation in their state clearly make the plant-based meat is different from their traditional meat industry product. I think time is up already, so I would like to complete my presentation here.
네, 저희가 5분 늦게 시작해서 질문 한두 개 정도를 드릴 시간이 있을 것 같습니다. 그 청중분들 중에서 질문하실 분이 있으면 손을 들고 질문해 주시기 바랍니다.
서울여대 노봉수입니다. 그 하이 모이스처 익스트루더를 사용하는 이유가 그 원료 자체의 그 어떤 친수성기를 기대하는 건지요. 그래서 이제 친수성기들을 유도해서 이렇게 만든다고 하는 경우에 나중에 만들고 보면 거기 향 성분이 들어가야 될 텐데 향 성분들이 상대적으로 친수성기를 띠질 않고 소수성을 띠다 보면 이게 요리를 하고 난 다음에 향기 성분이 빨리 휘발되어 버리지 않겠는가 그런 생각이 들어서 그런 문제들을 어떻게 극복할 수 있는지 궁금합니다.
예, 좋은 질문입니다. It's all about flavor because generally high moisture extruder use a very high shear and high temperature. That's why it may have chance to lose the flavoring agent. 그렇지만 다른 점이 있습니다. 다른 점이 dry extruder에 비하여 high moisture extruder를 사용할 경우에 barrel temperature가 굉장히 낮습니다. 일반적으로 barrel temperature가 한 섭씨로 얘기해서 그러니까 product temperature가 130 degree Celsius 정도 되면 뒷단에서 쿨링 다이가 그 스팀 프레셔를 받아주지를 못합니다. 그래서 이 오퍼레이션 자체가 드라이 익스트루전보다 굉장히 마일드하게 한 상황이 돼서 템퍼러처가 상당히 낮아요. 한 110, 120 뭐 이 정도에서도 러닝 할 수 있습니다. 그래서 온도가 일단 낮다는 게 특징이고요. 그래서 플레이버가 빨리 나가는 게 방지된다는 거고, 그리고 또 하나는 드라이 익스트루전에 비하여 에어로 그냥 팍 터져 나가는 게 아니고 그대로 갇혀 있는 상태에서 쿨링 다이를 통해서 다시 쿨링이 되기 때문에 도망갈 곳이 없습니다. 그래서 그 안에서 다시 캡처돼요. 그래서 이제 플레이버를 막을 수 있지만 그러나 열에 의한 플레이버 머티리얼의 변성은 막을 수가 없겠죠. 예, 그렇게 컨트롤하고 있습니다. 그래서 지금 당장 아마 여러분 회사나 여러분 실험실에서 사용하고 있는 하이모이스처 익스트루드하고 제가 디자인한 거 좀 틀린 건 많이 보이실 거예요. 단백질이 여러 개를 섞기 때문에 각 단백질의 히트 제너레이션 메커니즘이 다 다르고 젤레이션 메커니즘이 다 다릅니다. 거기에 맞춰서 컨피규레이션을 다 바꿔줘야 돼요. 그리고 프로틴이 들어가는 부위도 다 바꿔줘야 돼요. 거기에 맞게. 그래서 맥시마이즈, 그 펑션을 맥시마이즈해서 만들어야 되고, 그리고 쿨링 다이를 지금 사이즈 말고 대부분 쿨링 다이가 스크루 다이 길이보다 훨씬 길어야 효과가 좋습니다. 그래서 쿨링을 충분히 시켜서 나올 수 있게 되면, 그러면 앞단에서 온도가 아무리 올라가나 스팀 프레셔가 아무리 올라가도 뒷단에서 익스플로전 되는 걸 막아줄 수 있기 때문에 쿨링 다이를 훨씬 길게 끌고 가시는 걸 추천합니다.
네, 혹시 플로어에서 다른 질문 없으실까요? 박사님, 제가 그 시간이 얼마 남지 않긴 했는데요. 아까 보다 보니까 그 버전 1, 2, 3, 4 이렇게 보여주셨잖아요. 사실 사진 보면서 버전 1은 저게 뭐야? 저게 지우개인가? 이런 생각을 안 한 건 아닌데, 버전 4를 딱 보여주셨을 때 제가 어떤 생각이 들었냐면 저거 스트링 치즈 아니야? 뭐 어디 그 당나귀 우유에서 나온 색깔을 보고 제가 그럴 생각이 굉장히 제가 파이브러스하다는 그런 느낌을 사진으로 많이 받았어요. 예. 제 질문은 실제로 그 이제 파이브러스한지, 저희가 이제 사실 파이브러스 프로틴이 타겟팅이잖아요. 플랜트 베이스드 프로틴을 이제 미 프로틴을 만드는 과정에서 이렇게 진짜 찢어지는지. 두 번째 질문은 단백질이 여러 가지 섞이고 저렇게 이제 하이 히트이 들어가게 되면 사실 아까 그 노봉수 교수님께서 말씀하신 것처럼 플레버에 대한 거를 마스킹 할 수밖에 없을 것 같은데, 예, 그 플레버는 이제 어떻게 그 나오는지 버전 4에서, 예, 저도 실제로 가서 한번 보고 싶은데 한번 먹어보고 또 보고 싶고 한번 해보신 분이시니까 제가 이렇게 한번 여쭤봅니다.
네, 우선 파이버 포메이션이 익스트루더를 사용하는 첫 번째 이유이기 때문에요. 무조건 첫 번째 이유는 만족하고 가야 되기 때문에 익스트루더는 머슬 파이버를 만들기 위한 기계다라고 그거는 베이직으로 깔고 가야 됩니다. 그래서 머슬 파이버를 만들지 못하는 상황에서 다른 걸 그 내 익스트루더 가지고 하겠다라는 생각은 별로 좋은 생각이 아니겠죠. 머슬 파이버는 익스트루더에 의해 만들어진다. 그걸 위해서 내 익스트루더가 최적화돼야 되는데 그건 기계적인 최적화만 생각하지 말고 단백질의 구조에 대한 거 최적화를 같이 생각해야 됩니다. 그래서 SPI를 사용할 경우에는 몇 도 정도에서 디내추레이션 됐다가 몇 도 정도부터 다시 지들끼리 붙어갖고 3D 스트럭처를 만들어주는지 그걸 알아야지 오퍼레이션 컨디션이 나오죠. 또 하나는 예를 들어 윗 글루텐 프로틴 같은 경우는 이게 메커니컬리 니팅이 돼서 3D 스트럭처를 만들어주니까 내가 익스트루더 바렐 안에서 스크루 컨피규레이션을 어떻게 잡아줘야지 윗 글루텐이 제대로 형성될지를 알고 거기서 그걸 만들어줘야 되거든요. 그래서 보시다시피 제가 보여드렸던 익스트루더는 단백질 들어가는 구멍이 2개 있었습니다. 그렇죠? 왜 그런지 이제 이해하시겠죠. 물론 돈이 많아서 익스트루더를 2대, 3대를 한꺼번에 놓고 코익스트루더에서 얘는 디자인 자체를 윗글루텐용으로 전용으로 디자인하고 얘는 소이로 하고 얘는 멍빈으로 하고 그렇게 해서 다 바꿔갖고 템퍼러처를 다 맞추고 컨피그레이션 다 맞춰 해서 코익스트루더 전 방식으로 뽑아내는 게 사실은 제 마지막 골이에요. 네. 그러니까 다시 말씀드리지만 익스트루더의 오퍼레이션 컨디션은 로 머터리얼의 케미스트리하고 아주 완전히 연결이 되어 있기 때문에 거기에 맞춰서 디자인을 해주시면 이제 좋은 이제 결과가 나오겠고요. 아까 말씀드린 플레이버는 열변성에만 문제가 없다면, 그리고 말씀드린 대로 익스트루더 템퍼처가 과히 높지를 않아요. 일반 건식 익스트루더보다. 어떨 경우에는 뒤에서 가스를 밀어넣어주게 되면은 한 섭씨를 한 80도, 90도에서도 익스트루전을 할 수가 있어요. 프레셔가 중요할 경우에는 프레셔만 밀어넣어주면 되니까요. 콜드 프레셔를 넣는 거죠. 그렇게 되기 때문에 플레이버에 대한 것도 저는 여러분이 알고 계신 대기업 플레이버 하우스의 글로벌 플레이버 컴퍼니하고 다 협업을 하면서 이걸 진행을 했습니다. 각 플레이버마다 다 틀려요. 그래서 한 개 플레이버만 사용하면 안 되고요. 각 플레이버의 프로파일뿐만 아니라 프로세스 중에 변질되는 거 이런 걸 감안하셔서 섞어서 사용을 하셔야 됩니다.
네, 오늘 이렇게 귀중한 실험 데이터도 공유해 주시고 멀리 미국에서 오셔서 저희에게 이런 좋은 정보를 주신 언리미티드의 한정훈 박사님에게 큰 박수로 보답을 해드렸으면 좋겠습니다. 박사님 너무 감사드립니다. 자, 이것으로 세션 2인 Plant-Based Alternative Food Current Standard and Future Direction에 대한 세 분의 연사를 모시고 한 세션을 모두 마치도록 하겠습니다. 오늘 장시간 시간 자리해 주셔서 너무 감사드립니다.
고맙습니다. 두 번째 세션 진행해 주신 대구대학교 식품영양학과 이미령 교수님께 진심으로 감사드리겠습니다. 그리고 발표해 주신 세 분의 연자 여러분께도 감사드리겠습니다. 저희 잠시 휴식 후에 세 번째 세션 이어가겠습니다. 역시 유익한 시간으로 준비되어 있으니까요. 잊지 말고 여러분 함께해 주시기 바랍니다. 그리고 저희가 설문조사 진행하고 있습니다. 이미 설문조사 작성하신 분들께서는 이동하실 때 저희에게 주시면 저희가 취업해서 다음 컨퍼런스 심포지움 진행하는데 큰 도움이 되겠습니다. 설문조사 작성도 한 번 더 부탁드리겠습니다. 잠시 후에 뵙겠습니다. 고맙습니다.